the triangle inequality theorem, part of it. And it says that the sum of any two sides, it has to be greater than the third. So there are three inequalities you've got to check, and you have to make sure that all three of them are true. If one of them fails, then a triangle cannot be formed. You got to make sure, and so I just have this diagram A, B, and C, where A, B, and C just represent the three side lengths. So when I add up A and B, that's got to be greater than C. When I add up A and C, that's got to be greater than B, and then B and C, that's got to be greater than A. When you add up any two side lengths, it's got to be bigger than that remaining one. And we did a little example why. They have to come together and form that third vertex. So here I give you an easy example of 10 inches, 15 inches, and 21 inches. These are three segments. And I said, could you create a triangle with these three segments? And yes, because all of them checked out. What's happened with number 2, though? Number 2 has 9 centimeters, 12 centimeters, and 21 centimeters. And so you would solve this problem the exact same way. You would test these three inequalities. So you first need to determine which side is going to be A, B, and C. So I just list them in order. This is A, B, and C. We need to check the three inequalities. So when I add up B plus C, is that greater than A? We've got to check that one. And then what if I add up A plus C? Is that going to be greater than B? And then the last one we need to check is A plus B, is that going to be greater than C? It doesn't matter which order you do them in, as long as you check all three of these situations. Make sure that it is bigger. But remember, like right now, it's kind of in question. We don't know yet, so that's like a question mark here. Is it bigger than? Is it bigger than? It needs to be, because if one of these fail, then the triangle cannot be formed. So plugging in our values. 12 plus 21 is bigger than 9. Is that true? Uh-huh. Very true. This second scenario. So 9 plus 21, is that bigger than 12?
Yes.
Yes, very much so. So check that one. Yes, we're good. Now the last one. 9 plus 12, is that greater than 21? Well, 9 plus 12 is what?
21.
Okay, is 21 greater than 21?
No.
No. This is a false statement. It doesn't say is it greater than or equal to. It must be greater than that third side. And so when I had the markers up here, and we were doing these examples here, we had one segment of markers, and the other two segments just laid flat on it. That's exactly what would happen in this case. So let's say that this segment here was 21 centimeters. Well, the other two, if I put one here and said, okay, well, this is 9 centimeters there, and then the other segment is 12. Oops, got those numbers mixed around. Those two would just fall flat, and it would be just flush. It would be like a large segment and two on top of it. So this is not a triangle. It needs to be greater than. So this, number 2, you would say no. This does not form a triangle. And you would have to explain why. The explanation would just be, well, when you add up the two smallest side lengths, it's not greater than the third. Now these problems can be done pretty quickly if you use just a little bit of logic. C is already the greatest number, right? 21 is the greatest number. So when I add something to 21, well, it's already bigger than 9. 21 in and of itself is already bigger than 9. So if I'm going to add something to it, obviously it's still going to be bigger. Then over here, 21, it's the largest number. So it's already bigger than 12. So even if I add something more to it, it's still going to be bigger. So if you use your logic and common sense, you really don't have to check these. The one that you really need to be concerned about is what happens when I add up the two shortest lengths. Is that bigger than the third? Because that's the one that you're really concerned about. Okay, so you got to look out for this one. This is the one that will fail this test here. When you add up the two smallest lengths and compare that to the longest one. Okay? Any questions about this? Determining whether or not a triangle can be formed. All right, you'll have a couple of questions like that on the quiz tomorrow. The next thing we're going to talk about is the relations between interior angles. Let me erase this. The relation between interior angles of a triangle and their opposite sides. That's what we need to start looking at and investigating. Like, what happens if we make the angle bigger? What's going to happen to that opposite side? And if we have two sides that are congruent, but this angle is smaller, what happens? So go ahead and label this. Relations between interior angles of a triangle and their opposite sides. By that, I mean I'm talking there, okay? That's interior angles. So between interior angles and the interior angles opposite sides. That's what we're comparing and investigating right now. You guys have already seen this before in previous math classes because you know the Pythagorean's theorem, correct? So let's say I had a right triangle here. And you labeled this A and B and C. In a right triangle, what was always the longest side? The hypotenuse, C. That was always the longest side. That's what your teacher told you. What about A and B? Like in this diagram, so we know that C is the largest. C is the largest. Just based off of the diagram, just for this example, because usually I've told you don't go by the example, but what seems to be the next largest side? B. C is in the middle, and then it looks like A is the smallest, or the shortest. Well, the three interior angles of all triangles have to add up to be what? 180 degrees. So if you have a right triangle, that right angle is taking up 90 degrees of that 180. So that means the other half, the rest of the 180, 90 degrees is left over for your two acute angles. So I just said that this kind of looks like 20. That would make this 70. So when I'm referring, so what you just wrote down was we're looking at the relationships between interior angles, that's these three interior angles, and then their relationship to the side that's opposite them. Well, segment A, or this length here, is opposite angle 20. That's that angle of measurement. And so it's opening up to this side. That's its opposite side. And so, and then this angle at 70 is opening up to this side. So that's the opposite side. We've seen this before in this class, and we said that the opposite side of the right angle would be the hypotenuse. And you should have seen that in 8th grade math or 7th grade math, or wherever your level was. Well, what is true always, happens in triangles, is that the largest angle is going to be opening up to the largest side. And that should make sense because if I'm an angle right now and the side, the opposite side, is the distance to my fingertips, well, as I make the angle bigger and bigger and bigger, my hands are getting further and further apart. So the larger the angle, the larger that opposite side has to be to accommodate the angle measurement? Well, 90 degrees in a right triangle, it's always going to be the largest angle in a right triangle. That's why the hypotenuse is always the longest side. So C, that length, would be the largest, which makes that right angle the largest angle, and then B looks like in the middle because 70 is in between 90 and 20, and so on and so forth. And so, what always happens in triangles is that the largest angle is opposite the largest side. And then the shortest side is always opposite the smallest angle. So the largest, and I just put in parentheses the longest side, will be opposite the largest angle. This is always true. The largest side has to be opposite the largest angle. And also the shortest side, or the smallest side, is always going to be opposite the smallest angle. The bigger the angle, the bigger the opposite side. The smaller the angle, the smaller the opposite side. All right, so we should have that jotted down. And so here's an example for you right here. I need you to write down this example. It says list out the angles and sides. So we have triangle ABC here. List out the angles and the sides in order from least to greatest. I need you to write this question down so that when you go back and look at your notes, you don't just have answers. You actually know what the question was that you're answering. List out the angles and the sides in order from least to greatest, or smallest to largest. Same thing. And this is the triangle that you're going to be using here. Now, on my tests and sometimes on standardized tests like the SAT or even like you take a STAR test, they're not going to give any information away by the diagram. They're going to see, do you truly know these theorems? This triangle kind of looks like an equilateral, equal angular triangle, does it not? Okay, but you need to go by the numbers. What I said is, this angle is 91 degrees. This angle here is 20 degrees. This angle here is 69 degrees. Like, obviously, those are not the same measurements, but it looks that way. So sometimes the diagrams, the reason they do this is so that they are not giving away any information just strictly by the diagram. They're saying, okay, do you know this theorem? Yes or no? So please go ahead and list off the angles and the sides in order. Use proper notation. You will lose points on the quiz next class if you don't use proper notation for segments and angles. Okay, take a look at this triangle, triangle ABC. We know that it has three interior angles, angle A, angle B, angle C. It has three sides, segment AB, segment BC, and segment AC. I've asked you to list them from least to greatest. Let's do the angles first, because I think that's the easiest thing, because I actually give you the angle measurements. So you have angle B, that is the smallest angle. Next one, angle C, and then angle A. This is from least to greatest, the easiest part, because I actually gave you the angle measurements. Now, let's look at the side lengths. Okay? You don't know any of the side lengths, but that's okay. You can tell me. You can list them from least to greatest. So what is going to be the shortest segment in this triangle? Segment AC is going to be the shortest side because it's opposite the smallest angle. So that angle opens up less than the others. And then what is the next segment? The one in the middle? Segment AB. Could I have called that segment BA? Yes. Remember that each segment has two appropriate names. You can interchange the endpoints. And then the last one, well, by default, it's got to be segment BC. But more importantly, you know that angle A is 91 degrees, so the side opposite, segment BC, has got to be the largest one.